So what we're going to be doing is starting off and creating this mini golf game, and we're going to start with like I've already created this GitHub repository, but just to show you, it's a empty repository, and I created a branch for develop, which is where I'm going to work in today. And I've got GitHub desktop on my desktop, and I have the develop branch here open and last fetch. Like nothing has changed on this because I haven't changed anything about the project. And you can see here the initial commit just with the git ignore and stuff. So I'm just going to go back to the changes tab, and then I'm going to go to Unity Hub, and I'm going to create this project inside in that GitHub folder. So I'm going to create a new project, and I'm going to call this. I'm going to call this Mega Golf. And I want to navigate to that folder, so I have my GitHub stuff is in Documents, GitHub, Mega Golf, and that's my repository. So I'm going to select that folder, and I'm going to go with 3D as well because this is going to be a 3D game. I'm going to hit Create, and again, Unity is going to do its thing. It's going to install some of the different files and the sort of base assets that we need to be able to create our mini golf game. And once this is done, we're going to just move as we did in the GitHub demo tutorial or the Git demo, I'm going to move the git ignore into the top level of the Unity project just so that to stop what you will see here, we've 4,668 files changed. We don't need to worry about all of those. So I'm going to, so it's 4668. Once I go to that folder, I should really pen it there somewhere. Documents, GitHub, Mega Golf. This git ignore I just need to have at the top level of the Unity folder. Okay, and that's my git ignore file. And when I jump back here, that's only 28 files changed. Okay, so doing this just reduces the amount of stuff we're syncing across the server. It means any of the default Unity generated files aren't getting synced to the remote repo. And then I'm on the develop branch, which is important. I want to make sure that's the case. And I'm going to, just as a summary here, I'm going to say created empty Unity project and moved git ignore. And I'm going to commit that to develop, and I'm going to push that to the origin. Okay, so that's my first commit. That's just like the empty project basically there. So the next commit, I'm going to have some basic functionality working in it. Okay, so I'm now going to come back to Unity, doing something down here. Don't really know what. We'll see if we can keep working ahead without an issue. So I'm going to create, for this, I'm going to create a file, and I'm going to create a new scene. And it's going to be basic built in. And I'm going to save this. So Control S in the scenes folder. And I'm going to call this my test golf scene. And I'm just going to delete out that sample scene because I really don't want that kind of in the way or showing up. So this is my test golf scene, and this is where I'm going to be kind of creating the gameplay basically for this game. So the first thing I'm going to do is I'm going to work with initially just basic Unity primitives before bringing in Pro Builder, and that's just to get like kind of the basic functionality up and running. So I'm going to go game object, 3D object, and I'm going to create a sphere. Okay, and this is, I'm going to rename this to ball. Okay, by default, this has a transform component, so it exists somewhere in the world. It has a mesh filter, which just defines the shape of the object. It has a render that defines how it's displayed, what materials it has. It has a sphere collider, which means it can like interact with things and like bounce off things and hit off them, which is kind of important for what we're going to be doing. But like if I press play, okay, the ball just floats in space basically. I'm going to turn off maximize and play because we don't really need that at the minute. So I'm just going to add a component over here on the right hand side, and it's going to be a rigid body component. Okay, so just to show, Just to show how that works, I'm going to remove that. I basically come over here into the inspector with the ball selected, add component. If I start typing rigid body, I want to create a rigid body. If this was a 2D game, I'd be creating a rigid body 2D, but we want 3D, so we want like kind of 3D interactions and stuff. Use gravity is ticked, so when we press play on the game, the ball basically falls through space. Okay, and that's kind of like the first, like the most basic interaction we have. This ball now has physics and it falls through space. And I'm then going to create a 3D object, and it's going to be a cube. Okay, and I'm going to call this ground. And I'm going to come over here and I'm going to scale this down a little like that. And I just want to make a platform basically that I can play golf. Okay, so this is a 13 by 13 meter platform. One thing to know at the minute, the ball is actually quite big. At the minute the ball is like a 1 meter, basically like 1 meter. And that's probably too big for a mini golf game. So I'm going to set the ball to be like bigger than a ball would be in a real mini golf game, but kind of good for video game size because you want things to be a little bit bigger. So maybe 0.1 or so. Okay, and then I'm just gonna move the height of this to the ball. Or sorry, we can actually see the physics here. If I leave it there, you'll see the ball should land, and basically it lands with a thud. Okay, so it doesn't really feel like our mini golf ball yet, but we have kind of a basic interaction. We have a ball that lands on the ground. So I'm going to just leave that there. I'm trying to think what the... Yeah, let's create a couple of materials first. So I'm going to come in here and the assets folder. Sorry, that's not... I clicked that by mistake. I'm going to create a new folder inside my project, and I'm going to call this materials. And inside here I'm going to right click and I'm going to create a, if you give me material, and I'm going to call this ball, and that's white, and I'm going to just drag that onto the ball game object, and then I'm going to duplicate this, so hit Control D on the keyboard and then select this. I'm going to rename that to ground. I'm going to drag that onto the ground, so I can drag it onto the scene view or the hierarchy, it doesn't matter which, and I'm going to change the color here to green, something like that. This, yeah, good, that's fine. We're going to change these materials in a little while, but for now that's fine. And we can press play. See the white ball lands on the green sort of ground that we have. So the reason we're developing the game this way is that we have a very basic setup, and we're just like trying to basically test out like the bare minimum at first. And one thing I might do is, yeah, I'm going to create a game object and I'm going to create another cube. And I just want to have something to practice like bouncing the ball off, so that once we have functionality in here. And I'm going to hit Control D, E on the keyboard. That creates a duplicate. And I'm not too worried about the layout of like this object. It's just really a little like kind of test scene. But I'm also going to create a new material here, and I'm just going to call it walls. And I might set the color to kind of a reddish color. And I can drag it onto that and that. And we're kind of starting to create the design of the scene we're looking for. Yeah, the other thing then I want to do is I want to make the camera at the minute, okay, what the camera is a perspective camera. And that means it kind of represents the perspective we see with our eyes. So if I'm just going to maximize this tab. So basically, as we look straight on at something, it has these what are called vanishing lines, and they kind of approach a point infinitely far away. So these lines converge, and that's kind of how we see the world. Like it's the way our eyes work. But there's another way to see things, which is orthographic, which represents like kind of and a view from infinitely far away along infinitely straight lines. So these lines wouldn't converge; they'd stay parallel from one another. And we're going to go with that for this because if you ever play games like I try to think of some of the games like Monument Valley or anything like that, they kind of have like a cute sort of perspective view, and for this type of game, it's going to make it a bit more clear what's going on to not have perspective kind of interfering with things. So one thing I'm going to do as well is on the camera it has clear flags, and I'm going to change that to solid color. And that means it's not going to render the skybox anymore, just the background of the camera is going to be currently blue, and we can click that box there, and we can change the color of that to like this sort of grayish, slightly bluish gray. And I can close that, and yeah, cool. And then instead of perspective, I'm going to change the camera angle to orthographic, and as you can see there, it's like this perfect view. It's like an engineering view basically, or something like that. And like as I rotate the camera, so if I rotate the camera downwards, it creates this perfect view. So if you've ever played like 2D sort of RPGs or stuff like that, or like the early Zelda games, it's this sort of perspective you have in the game. So on the x-axis here, I'm going to set this rotation to be something precise. I'm going to say 30, and I'm going to do 45. And then I'm going to just try and frame up the camera a bit better here. You'll see some of the ground gets cut away if I get the camera too close. That's because the camera has what's called a clipping plane, so it just won't render things too close to it. And just pulling the camera back lets us kind of resolve that issue. Now, at the minute, I'm a bit too zoomed out. So what I can do is come towards the size, and as I make the size of it smaller, it zooms in kind of the way I want. Okay, so now I've got like my little mini golf game, and it's showing me kind of how it looks in some realistic manner. I can press play, and the ball will fall. We won't really see much because we're a bit too far away. That's fine. That's our scene. Basically, our scene is set up. Our game objects are set up. So I'm now going to save this, and I'm going to head back towards GitHub, and it shows me here the things I've changed. So I'm just going to say created test scene and game objects. Something like that. I haven't done too much, but it's a useful point to commit. If I was working with someone else and they needed to work with this, and like I'd push this to Origin, I don't need to do that now. I can if I want, or else I can make loads of changes and push this later on. But like if my computer crashed, this and something happened to my hard drive, I'd lose this, so I can actually push that. So I don't want to lose any work, to be honest. These lines here, I think, are just it's just the way it's rendering the scale of that view. Basically, it's not an actual artifact we'll have if we play the game. It's just I don't know, it's the way it's compressed this image size. I don't know why it's doing it. It's not the nicest thing in the world, but it's not there when we actually play the game. Cool. So the next thing we're going to do is start implementing some code. So we're going to go and create a new folder, and we're going to call this scripts. And we're going to create a C# script, and we'll call this ball movement. And I double click that. It'll take a second because JetBrains Rider, which I use as the IDE, will need a few minutes to kind of come online, and install some Unity requirements to make sure it's synced up with the editor and stuff like that. Okay, that's all on there. It tells me here Git can't run. I can use Git from inside in JetBrains if I download and install. It's a useful thing to do. It's a thing I would tend to do quite a bit. So I'm just going to jump back into Unity and I'm going to put the ball movement script onto the mini golf ball. And you'll see here, it's a script here. It has no functionality, and that's because we haven't given it any way to do anything. So to explain the structure of this this script, these are directives basically that if we're using certain things, they're useful. So collections.generic allows us to use things like lists and things like that. We can delete them out if we're not using them, but Unity kind of assumes there's a good chance you'll be using them, so it just gives you them in the default script template. I normally end up deleting them out if I'm not using them, but you don't have to. We then have the class name, which is ball movement, and it's a public class. This here means it inherits mono behavior. So a mono behavior, basically, all it means is it's a specific type of Unity script that allows us see it in the inspector. Okay, if I take this out, if I delete out mono behavior and save the script, we'll no longer see that in the inspector. Okay, so it's giving us this issue here basically, so that we won't be able to run the game until we fix that, because we've tried to attach a script that is not a mono behavior. So I'll just undo. Okay, and that's what mono behavior inherits. It's that editor functionality basically. And then we start, which is called like before the first frame update, and it's just like it kind of allows us to initialize values and things like that. And then we have update, which is called every graphics frame, and with a lot of other calls, when we're working with physics, which we'll be working with in a few minutes, we're going to actually create a new function there called fixed update. Now, I like to just delete this out and just start with an empty script, because it makes it a little bit easier to see everything we're adding in. And I'm actually going to just delete out these, and if I need them, JetBrains will actually create them for me. So I'm starting with like a very basic script, but this is all that I need basically to start off working with. So I'm going to create a couple of variables. So the first is going to be called, it's going to be a private, and it's going to be, capital R, rigid body, and I'm going to call this my RB. Now, the reason, you've probably come across public and private before. And oftentimes in Unity, you will see people make things public because they want to edit them in the inspector. That's not an approach I love, because it can lead to some issues. It can mean someone basically ends up changing a public variable when really you didn't want that script or whatever it is to access that public variable. For most of the scale of game you're going to be doing, it's not going to cause an issue, but I think it's better practice good habits rather than bad habits. So as a basic rule of thumb, if something is only going to be needed within this class, so I only need access to this rigid body within the ball movement script, it should be private. Okay, I've no need for anything else to access it. If I might need to access it or change it in other classes, I can make it public if I want, or I can use getters or setters to change it basically with public attributes. For now, with something like this, it's better leave it private, and I don't need any access. I don't need to change it in the editor. I don't need anything like that. So this is going to be private. And then I'm going to create a variable for, I'm going to create a private float, and I'm going to call this maybe I'll call it shot power or something like that. Okay. Now, if I want to initialize this, I can do equals, let's say 10 or something like that. Okay, and that'll initialize this value at 10. One of the benefits of Unity is we want to be able to, clear these. I think it should be fine. Yeah. I'd like to be able to edit that private variable here. Now, if I make it public, okay, I can edit it there. The danger with that is, let's say someone else is working on this project and they're like, they try and get the value for shot power, like they're trying to see what the power in the shot was because they're doing something to like average out your average shot power or something across the course, and they end up changing that variable to 0. They've now changed a variable that really I didn't want them to be able to change. So there is a way we can have this be private. Oh. We can have it be private and we can set the value in the inspector. Okay, instead of initializing it there, we can set this in the inspector by going encapsulating this with square brackets and typing in serialize field. Okay, and what serialize field is going to do is it's going to serialize this in the editor, and it's going to allow us access this private field from the editor, which gives us the best of both worlds. We have access to it here in the editor, but it's also a private variable. Okay, and that's a very useful thing to be able to do because it allows us and I'm going to set this just to 1 to start off, and then we'll see kind of how it's useful to be able to change that. Okay, so that is our shot power, and then I'm going to create a couple more, you know what, just Control X. I'm just going to move that to there, just so that I put any serialized variables up there, just so that my code is a little bit neater or tidy. I'm generally not the best at being neat and tidy with my code. The other thing is, once I save this scene, okay, that value there is 1, and at the minute JetBrains says this is unchanged, but once I save my scene, and if I come back to JetBrains, it knows that value in the editor is 1. Okay, so that's kind of one of the nice things about JetBrains as an IDE. It allows us know, like, kind of see editor values within the code, so we kind of have a good idea of, oh, what was that value set to again. Then I'm going to create a private float, and this is just going to be a way to store, I'm going to call it shot force. Okay, and this is just going to be the kind of force that's used for the shot, basically, and this will depend on how far I pull back the mouse. Okay, and so we're going to have hopefully a nice little interface for that. Then I got to create some private vector trees. Vector trees are 3-dimensional vectors that are basically like X, Y, and Z is a vector tree. It's to explain what a vector tree is, X, Y, Z. A vector tree basically looks something like that. It has 3 different values, 3 different float values basically stored in a single struct vector tree. Hopefully that makes sense. If it doesn't, just know that vector trees let us store 3 pieces of information, or 3 floats, not any type of information. So vector tree, I'm going to have my start pause, I'm going to have my end pause, and I'm going to have direction. Oh, sorry, this should be a comma here. So start pause is going to be when I click down the mouse, that's where I'm going to like first click. End pause is where I release the mouse, and direction is going to be the angle that line creates, basically. Okay, and then I'm going to create a private bool, and I'm going to call it can shoot. Because it's a bool, it's going to default, just like shot force will default to 0, can shoot will default to false. If we want to be extra safe with our code, we can hit false. I never really do that, I just let it set to default. Okay, but basically know that when you initialize a boolean value, it starts off as false. Okay, cool. So there we have a ridge body, which is going to like be how we control our physics. We have a shot force, which is going to be how we work out like what the actual power, what power we're applying to the ball. We have a start position of the mouse, end position of the mouse, the direction we want to drive the ball in, and whether we can take a shot or not. So we're going to end up doing things like, if the ball's moving, we're not going to be able to take a shot and stuff. And then we have a shot power variable, which lets us just tweak this shot for us. Okay, so it allows us some sort of control over that in the editor as well. So I am going to create a start method. Okay, so again, it's private void start. It's a little bit like, you don't need to do it. You can use the built-in ones. I just find it easier to create what I need. My RB. Okay, so this is this value here, and you can see it no longer is highlighting it as an unused variable. So it says my RB equals, and I'm going to get a component of this game object, and the type is going to be rigid body. Okay, and that means when the game starts, I'm going to, at the start loop, or at the start initializing, or whatever you want to call it, start frame, what I'm going to do is save a reference to the rigid body component of this game object. So if I'm just going to save that. Okay, and there's the rigid body component. Okay, so it's going to save a reference of this. There are things we can do there, like, we'll come back to it later on, but basically we might want to check to see, like, we might want to do, let's say, if get component rigid body does not equal null, then basically get the rigid body. Okay, so that's just a check to make sure that like there is a rigid body component. Okay, so if that component isn't null, we're gonna assign it to that RB value. Because we kind of need a rigid body component, there's a way we'll come to later on in the module where we talk about like just required components. So we can say basically only attach this script to an object that has a rigid body, and if the object doesn't have a rigid body, just create a rigid body for it. Okay, so that's my RB. Cool. So then we're going to come down into the update method. Okay, and we're going to go, please start typing update. It's going to create the update method, and I'm going to go and get some input. If input, and I'm going to get mouse button down, and that's going to be the frame in which the mouse button is pressed down, and mouse 0 is left click. Okay, this is stuff that comes with practice. If you like Google how to get like left mouse click, that's something like this will come up. Okay, so I'm gonna create this method, and that's it. Okay, so this is going to give me some kind of code or functionality for this. Then I'm going to come in here, and if input dot mouse button, which means it's held down, and mouse button 0. So there's kind of 3 stages that I need to account for here. So I need to think of when I click the mouse, when I'm holding the mouse button down, which is this one, and then when I release the mouse. So if and input dot get mouse button up. Sorry, where's that? Get mouse button up and 0. Okay, and I'm gonna account for the different functionality inside here. So what I'm going to want to do is to create a function that gets me like where the mouse is at the current point in time. So to do that, I'm going to create a new method down here, and I'm going to call this it's going to be a private vector tree, and I'm going to call this mouse position. Maybe mouse position in world or something like that. Okay, so this method is going to return where the mouse currently is in the world. So I'm going to want to find out where it is at the start, where it currently is, and where I release the button. Okay, that's basically what we're going to be doing with this. And because I'm using this code again and again and again, we can we kind of want to create a method as opposed to like repeating the code inside each of these methods. So inside here, I'm going to create a new vector tree. and I am going to go vector tree, and I'm going to call this position, and I'm going to create this as a vector tree.0. Okay, and a vector tree is basically a vector tree where the x, y, and z components, the tree components, are all 0. Okay, so it's like, you can kind of think of it like an empty vector tree, or vector tree where all values are 0. There's also like vector tree up where the y component is 1, basically. So there's some built-in kind of vector tree functionality. Then what we're going to do is we're going to create a variable. So this is going to be a array. So what we're letting Unity here do is decide the type of this. Sorry. So we're going to call this array, and we're going to go from camera.main dot screen to point array, and we're going to go input dot mouse position. Okay, and what this is going to do is it's going to create a array, basically, which is like kind of a line from the camera, from our main camera, to the mouse position. Okay, so it's going to like translate array from the camera view into the world, basically, and that's what we're trying to do there. We're trying to convert from screen space coordinates to world space coordinates, and then we're going to create a raycast hit, which is how we get information out of a raycast. We're going to call this hit, and we're just going to say equals new raycast hit. Okay, and that's how we're going to get the information out of this. So then we're going to do if, and then we're going to do our raycast physics.raycast, and we're going to do ray, and we're just going to get the hit information out of that. Okay, and all this is doing is it's using the physics engine to generate a raycast using this ray. So it's going to go from the physics engine, it's going to say, okay, cast out a ray forward from the camera to wherever the mouse is pointed at, and output some information about where it's hit. Okay, so then we can say position, which we've created up here, equals hit dot point. And we can now go return position. Okay, so that's going to send this value back. Okay, and that's this piece of functionality basically sorted for us. Okay, so we I don't think we need to come back to this today. I think that should work fairly well for us, and there's other things we'll be adding into this in a little while, but for now this lets us get the basics. Okay, so we're going to do, on our first click, we're going to say start pause equals, what did I call that? Mouse position in world. I think that's just telling us it's expensive, yeah, but that's fine. In here, we're going to say our end pause, and we're going to do mouse position in world. Okay, and when we release the mouse, we're going to do can shoot equals false. Okay. Cool. Yeah, we don't have to worry too much about this right now. Let me just check and see. So that's our update. The update is basically the rendering loop. So it's like drawing things on screen basically and running the code in the background. Our physics runs in a separate loop, and physics is normally at, I think, 30 or 60 frames a second. I'm actually not certain on that, I just need to double check. But basically, we have a separate loop for physics, and if we try and change the physics values in the graphics update loop, if they're anyway out of sync, we won't actually get the input basically. Sorry, I need a semicolon there. So it means we'd basically have issues where we're trying to like hit the ball and it's not registering that we're trying to hit the ball. So I'm gonna go if can shoot equal, oh sorry, I haven't created my physics loop. So sorry, I'm gonna do fixed update, and that's our physics loop. Okay, so rendering and kind of most functionality happens in update, physics happens in the fixed update. So I'm going to do if can shoot, and I'm going to put an exclamation mark in front of that, so which means if it can shoot, which we've set to false here, and sorry, can shoot here to start. I actually want to start it as true. Okay, so I want people to be able to take a shot at the start of the game. So if you can't shoot because you're taking a shot, then we're going to say direction equals start pause minus end pause. Okay, so by subtracting these two vectors one from the other, we're going to get like the angle that we can shoot at. And then we're going to do my RB, sorry, my RB dot add force, and we're going to go direction times we're going to go direction times what did I call that, shot power, and then we're going to go comma and force mode impulse here. Okay, so there are different basically types of force. The impulse is like getting hit by something, basically. It applies an immediate force. And that's what we want to do there. Cool. And then we want to just reset start pause equals end pause equals vector3.0. Okay, so we're going to say they're reverted back to 0 vectors. And let's see if this works. I think we should have enough basic functionality in there for this for us to be able to click on the ball. Cool. So at the minute, we're very basically able to apply a force, but it gets out of control a little bit quickly, which is kind of cool. Cool. Okay, but we've gotten to the point where we have, we could say we have basic controls implemented. So I'm going to save that and save that. And I'm going to do commit at this stage so that if I break anything, at least I know kind of what I've broken. Added basic golf control. And I'm going to commit that. And I may as well push so that all my changes are uploaded to GitHub. Cool. So I'm now at a point where I've got like basic functionality, but there's a lot going on that really is kind of a crazy. One of the things you might notice is the further, basically, I can do like a huge force to this ball by like going at a further distance and stuff like that. So I'm going to want to add in some extra sort of checks and stuff like that. So I'm just trying to find my notes here and remember what I had done. Cool. So I have, let's use the shot power. I'm going to create another one called max force. Cool. Cool, that's my shot force. I've got all of that. In direction can shoot. Cool. So I'm going to do can shoot, and I'm going to create another variable here called shot started. Okay, I just don't want to be applying force until I've started taking, like while I've started taking a shot. Yeah, and that should give me enough functionality there to kind of do some of this kind of fancier stuff. So I'm going to say if input mouse down and can shoot, and up here in start I want to set can shoot to true. Okay, so if I'm holding left mouse button and I can shoot, then I'm going to do this, and I'm going to set shot started to true. Then I'm only going to be calculating this stuff, so I'm going to say and shot started, so that it's only going to be calculating this mouse position based on that. And then I want to do the same here. So it'll only check to see if I've released the mouse if I've actually started a legitimate shot. Can shoot is false. Shot started. Oh, sorry, that should be shot started. And I'm going to set that to false. Okay, cool. So that gives me some of that functionality. Cool. So we'll just see that should start behaving a little bit better. There's one more thing we're going to want to do, and that is we're going to want to kind of control the force a little bit better. So at the minute, until the ball stops moving, oh yeah, at the minute I haven't left about the code, so at the minute I can't really shoot again. Okay, so there's a couple of things I want to do. One is to control the power of the shot, and what I want to do is basically change how strong the shot is depending on how far back I pull the mouse. At the minute I'm just applying the force regardless. So you'll see up here we have this shot force variable that we haven't used yet. So I'm going to come in here into this here, and I'm going to say shot force equals, and I'm going to use the math functionality, mathf, which is built into Unity, dot clamp. Okay, and this is going to output a force between, it's like going to clamp it to a max and min value basically. So I got to go vector 3 dot distance, so that's 3 capital D, and I'm going to go between the end pause and the start pause. Probably would have been neater to do start and end pause, but that doesn't matter too much. Then I'm going to clamp that between 0 and my, did I create a max force variable? I did. And my max force variable, which I think is here. Yeah, that's a serialized field, so max force. Okay, so I'm going to go between 0 and whatever the maximum of that is. Now to make that work, the one thing I want to do is I just want to multiply this by the shot force. Okay, cool. Yeah, cool. So, and actually the other thing I'm going to do here is this direction value is currently like, it can grow bigger and smaller, and I want to normalize that. I want that always to be like inside a unit circle. I always want it to have a length of 1 basically, so the shot is only longer based on this code here and not in terms of the direction impacting the strength of the shot. And to do that I just do vector 3 dot normalize and that. Yeah, just encapsulate that. And that should be it. Now I'm gonna press play, and I think when I play I probably won't be able to hit the ball at all. Yeah. Okay, and that's because my max force at the minute is set to 0. If I set that to 1 there. Okay. Let me set that to 100 and just see. thing I need to do here is can't she is that true? Shot start is true. Set that false. Okay, cool. In the fixed update, one thing I want to just check for is if my rigid body is sleeping. So if it stopped moving, I want to be able to let it hit. So if my RB that is sleeping, then I guess that can shoot to true. And then I'm going to set my max force here to like 10 and maybe shot power to 5 or something like that. And there we go. That's behaving more like how we want. Once the ball stops moving, we'll be able to hit it again. And that's definitely an issue at the minute because we want to be able to hit the ball like it rolls a bit too slowly. So one thing we can do is create a new variable here, and we're going to call this min speed. And we are just going to say in the start method we're going to do myrb dot sleep threshold equals min speed. Okay, and this means once the speed gets below a certain value, we'll put the rigid body to sleep and we can take another shot. So if I select the ball again, and here, min speed, I'm going to set to 0.2. And press play. And you see there the ball stops much quicker. It doesn't kind of roll on infinitely. We can increase the drag here if we want. Might slow it down a little more. Yeah, we're going to do some physics materials in a minute anyway, because at the minute this is still rolling a bit too much. Oh, and then we've blasted it off the screen. Basically, you probably can't see that there in the video, but it basically shot across the screen. So that's our min speed. Yeah, we're clamping this to the position and the distance from the start pause and end pause. Cool. Okay, cool. So we can change our max force and stuff like that. We could tweak there to change how powerful that shot was. We have our min speed. I just wanted to double check and make sure we have our min speed. That's working. We have our shots starting. We have our shots being taken. Okay, cool. Okay, so we have most of the kind of core functionality that we need. I'm going to create a couple of new physics materials here. Or actually, I'll just create one. Physics materials lets control like how kind of objects bounce and interact with one another. And I'm going to call this let's say physmat or something like that. You might want, if you're having like ice or something like that, you might have higher values. I'm going to say like 0.6 is the bounciness, because I want this to bounce off the wall a bit better. And then I'm just going to apply this to the ball, to the ground, to the cube, and to this cube. Okay, so now if I press play, I might get a little bit more bounciness off of these. Yeah, that's behaving a little bit more like how I suppose I'd like it to work. I still think that min speed is probably a little bit too high. And maybe if I increase the dynamic friction, which is like the friction when things are moving, Still rolls a bit more than I'd like. Um, there's one setting actually I want to change here as well. If we go into project settings and physics, bounce threshold is set to 2 at the minute, and we want this to be really low value, so we want it kind of to bounce pretty easily. So I'm going to set that to 0.2, and that's edit, preferences, physics, and bounce threshold 0.2, and that's just going to give us some nicer like things bouncing off a wall a bit better. If we don't do that, sometimes things will stick to a wall a bit. I really need to change that min speed, it's very annoying. And maybe I'll make like that dynamic friction 5. I try to multiply the friction. I just try to get the friction kind of feeling nice. That the ball slows down pretty quickly. Still not slowing down as quick as I'd like. So I think one thing to do definitely is change the ball min speed to, let's say, 0.4. Max force I'm going to set to 5 because I think I can hit it a bit too hard at the moment. And shot power is like how much I'm multiplying the shot by, and I'm actually pretty happy with how that feels. So the ball should stop moving a bit quicker. It really does just roll on and on and on. I thought I'd change that drag, so I'm going to set that to 5, and maybe that will help a little in slowing the ball down. Yeah, cool. That's kind of more like... That drag might be a little bit too heavy, but that's kind of, that feels a bit better. So if I go for maybe 2.5. Yeah, that's how it kind of feels nice and kinetic and fast, and it stops pretty quick. Okay, I'm pretty happy with those variables. So then I'm gonna clip that, and I'm gonna say change physics and ball controls to improve game feel. And I'm gonna commit, and I'm gonna push that. Okay, cool. So that's the basics of that built up. Yeah, okay, there's a couple of things we're going to do now. Cool. Okay. I am going to create a... I think what's the best thing to work on next? I'm going to create something very simple to load the next level. So I'm going to create a game object, 3D object. I'm going to create a cylinder. And I'm going to scale that. Doesn't really matter how it looks at the minute. It's a target for me at the moment. I'm gonna then set that to is trigger. Okay, and this just means that instead of colliding with this cylinder, it's going to trigger off it. So it can kind of trigger some code for us. I'm going to call that whole target. I'm going to leave the mesh render on it. I'm going to take that off in a couple of minutes. But then I'm going to add a component, and it's going to be C# script, and it's called, what did I call it before? I'm just going to call it maybe load level on trigger. It's kind of a long name, and I'm just going to move that into the scripts folder. That's the wrong folder. And I'm going to double click that, and that's going to open that file. And this is a really straightforward script to write, because it really only does one thing. So we're going to go on trigger enter, which means when the ball enters this trigger. Nothing else is ever going. We don't have to worry about doing any checks here, because the only thing that's going to move in this game really is the ball. We're going to go scene manager. You'll see here it says in and Unity Engine.scene management. That's a directive that we don't currently have, but as soon as I hit scene manager, JetBrains Writer, and I'm pretty sure Visual Studio as well, will add that in. So it'll add in the directive for us. I'm going to go load scene. Okay, and I'm going to go scene manager dot get active scene dot build index +1. Okay, and what this is going to do is, and we'll actually just get an error when we first run this, but all it's going to do is just try and load the next scene in our game. And I'll show you how we set up the build index in a second. Okay, so I'm going to hit save, and now if I press play, there. Okay, I'm getting an error. It's saying scene with build index 1 couldn't be loaded because it's not been added to the build settings. Okay, so what I'm going to do is this whole target. I'm going to leave the mesh render there because it's useful for us to have. But I am going to scale it down a bit more because it's a bit too big. Oh. That's probably about the right size for a mini golf hole. And so this is basically going to be the target we're going to have, and I'm going to create a new folder down here. And I'm going to call this prefabs. And I'm going to drag this in here. And I'm going to drag the ball in there. Okay. And then I'm going to create a new scene. I'll save the previous scene when I open that. And inside here, what I'm going to do is create a 3D object. Create a cube. Gonna assign the ground material to it. Gonna save the scene there, and I'm just gonna call that level 1. I'm gonna go back here, and I'm gonna make the camera as well be a prefab, because I just have those rotations and things on it, and it's really just going to be easier for me if I can do that in the next scene without having to tweak those variables, because I want to save the same angles. So I'm going to delete out the main camera, and I'm going to get the main camera prefab. It's there. It's looking at where I want. If I reset this, cool. And now I'm going to squeeze that down. I'm going to throw the whole prefab for the whole target in here. Gonna bring the ball into the level here. Oh. Don't know how I fired the ball backwards. Cool. And there, there's that. Cool. Okay. So then I'm going to save that scene. It's kind of behaving how I'd like. Yeah, that's perfect actually. Then I'm going to go back to the task level. I'm going to go edit, project settings. Sorry, that's not what I'm going to do. I need to do build settings. So that's in file, build settings, add open scene. Okay, and if you remember, the code was looking for a build index, so this is now build index 0. And if I open level 1 and do the same thing, and add open scene, and go back to my task off level, and now once I get the ball in the hole and this level, it loads up the next scene. Okay. So it's a simple enough way, it's quite straightforward code basically. And again, I'm going to save that there. And I'm going to say added level 1 and scene loading. And commit to develop. There's one thing actually that I think is important to bring up at this stage. If I play in, and might be easier if I maximize this. So if I like fire the ball like that, if I try and click outside the screen here, it doesn't do anything because that raycast needs a collider to interact with. To fix that, all I'm going to do is create a plane. That's a quad, not a plane. Perfect. I'm just going to turn off the mesh render on that. And now if I press play, I can click off the screen or wherever I like, and it's going to accurately reflect what I'm doing with the ball. You can see there, it's currently like the ball can land on that, which is fine. Let's just check to see if, oh no, I can't do trigger. Let's see if we, yeah, go. We can actually then put the same piece of code on that, which is the level load on trigger. And we can do collision enter, and then we're just going to reload our same scene that we're in currently. So basically, if it collides with this plane, we're going to reload this scene. Go. Whereas if we hit off the target, it's going to load the next scene if we have one. Okay, because we don't have another scene at the minute, it's obviously not going to do that. So then I'm going to jump back into the task off level, and there's a few kind of visual things I want to do to help kind of finish up and make this feel a bit more polished. So the first thing I'm going to do is open up the ball, and I'm going to click on the ball prefab here, and I'm going to add a empty game object as a child, and I'm going to call this the shot renderer or something like that. And I'm going to add a component, and it's going to be a line render. It's going to have 2 positions. The width here is, oh, that's useful. This purple here kind of shows us what that's going to look at like. So I'm going to set the width to 0.1. That probably looks a bit better. Instead of using world space, I'm going to use local space. Yeah, that 0.1 looks good. I can right click here and add a key, which is just going to let me create a trail that trails back to 0 basically. Okay, so this is going to just draw out a little renderer for us, a little trail renderer basically. So I just want to make sure that that's all okay. Color, the alignment. Give it the same as the ball material and we'll see how it looks. Cool, and that's our render setup. We are then going to open up this ball movement script. We are going to add a variable for private, nope, not line alignment, line renderer, and I'll call it my LR for line renderer. You'll probably know what that is, hopefully. And then I can do my LR equals get component, but this time it's a component in children of type line renderer. So it's going to get access to that line renderer basically when the game starts. Cool. So when I start, cool, I am going to say my LR dot, what I'm going to do here basically is set this to active game object dot. So this is only going to be visible when I'm taking a shot. Okay, so I don't want this to be visible if I'm not. That's true. And then I'm going to set the start position of this. That set position, and if this is position 0, and I'm setting position 0 to be, yeah, the local position of this. Okay, so it's my LR dot transform dot local position. Okay, and that's like relative to the parent object where this is. So it's just going to create this at the very center of that game object. Cool. So then what we want to do is draw the shot render, or the line render every time we kind of move the mouse. So then we're going to go my LR dot set position, and this is going to be position 1. And here we have to do a little bit of maths on this. Transform dot inverse transform, hold on, inverse transform point, sorry, that's what we want there, and end pause. And that's because we want to transfer that from the end pause is currently a space in the world, and we want to convert that to the local position relative to this line renderer basically. So then we are going to do my LR dot set, sorry, dot game object dot set active, and we're going to set that to true, or sorry, to false. Okay. So that is that. So now let's see how this starts to look. I'm just going to set this shot render to be inactive when we start the game. It's giving me a null reference. Okay, I'm actually just going to, just to make this a little bit more straightforward, I'm gonna serialize field on this just to make sure. I think what might be happening there is that it's not picking up that line render at the start of the game because it's disabled. So what I'm going to do is delete out that line, save, and then when we come back to Unity and I open up the ball prefab, I should have a line render component there, which is this, and we'll see how this works now. Okay. It's drawing it as a black line, which isn't really what we want, but it's 90% of the way there. So we get this nice like effect for the shot we're taking. And because it's a prefab, it means we get that everywhere basically. Cool. So that is that. I just want to change the way that render is looking because we might need to. We can probably use default line render as the material, and I think we should get white. Yeah, cool. That's all I needed to do there. I'm not too happy. The starting width is probably a bit thick, so like 0.07 or something like that might look just a little bit nicer. Yeah, cool. Yeah. Otherwise, I'm pretty happy with that shot indicator. Gives me a good idea of where I'm shooting and the sort of force and stuff like that. Cool. So I'm going to save that, and I'm going to come back to GitHub, and it's going to go added shot indicator to ball, and commit that. So it's about every like 10-15 minutes. I probably, like, if I was normally working on a project, I probably wouldn't be committing quite so often. So I'm going to jump back into Unity, and what I'm going to do now is just create some very basic UI, and the UI is just going to show us the number of strokes we've taken. We'll be going, in a few weeks time, we'll be going properly into UI, but this will be the basics. So I'm going to go UI, text, and text mesh pro. Oh, actually, sorry, I've done that at the wrong place. I am currently in the ball prefab. So I'm going to go game object, UI, text, and text mesh pro. It's going to ask me to import TMP essentials. So I want to import that. That's like it's a method of doing better kind of UI information inside Unity. It's a little bit funny, but that is it. I'm just going to delete this out because it didn't seem to correctly create the UI there. There we go. Okay. I don't know why I didn't create it right first time. I'm just going to set that to 0. I am over here and I'm going to anchor this to top right of the screen, or maybe top left actually, is a bit easier for me. So then I'm happy with the position and how far left it is. I'm just going to change the Y value and bring it closer to 0. I might just move it a bit to the right there. Okay, and this is going to be my score. I'm going to maybe make the font size a bit smaller. My canvas at the minute, so if I press play and maximize, you'll see that like goes really small. So one thing I want to do is set that to scale with screen size. So if I select the canvas, screen space overlay, instead of constant pixel size, I'm going to go scale with screen size. So I might need to come back in here, make this font size a little bit bigger. Cool. Something like that. Cool. So there's my UI. That's kind of all I need to do. I'm just going to call this maybe strokes taken. So then I'm going to come into, I'm going to open up the ball game object and open up the script. I'm just going to move my serialized fields together so that my code is a little bit neater. And I'm going to go serialized field, and I'm going to create this as a private. I'm going to create what's called a Unity event. And this again is going to add another directive here for Unity events. What Unity events let us do is to like send a message to different game objects that are listening when something happens. So what we're going to do is say each time we take a shot, so each time we release the mouse, we're going to invoke this event. And this is going to be an event of type string. And I'm going to call this shot taken. So every time I take a shot, if I wanted to play a noise, I could use this to play that audio as well. I could add multiple events to this. And all I need to do is come down, and then I want a private string, private int. I'm going to call this strokes. And I'm going to go strokes plus plus, which is just going to add 1 each time I take a shot. Basically, I'm increasing the strokes counter by 1. And then I'm going to do shot taken, which is our Unity event. I'm going to invoke this with the strokes I've taken dot to string. So I need to just convert that to a string value. Okay. And that's going to then trigger this event, basically. So if I come in here, you'll see what a Unity event looks like. That's this here. Okay, it gives us this nicer UI. So we can now hook this up. So it says shots taken. What game object wants to listen to this? Well, I know it's this strokes taken UI. And I go to TextMesh Pro UGUI, dynamic string. The field I want to change is the text field. And now my UI should update as I play the game. So yeah, each time there I take a shot, it updates. Okay, and then I'm going to do the same with the UI. And I'm going to turn that into a prefab here. And then I'm going to go into my level 1. Save the changes here. Shots UI. Here we go. This might or might not work. I'll just have to reconnect this this here in each scene. Cool. So now I have working UI, level loading, all that sort of stuff. Okay, so that gives us the basics of a mini golf game. In the game, we're able to like take multiple shots. We're able to adjust the force. We have some prefabs. We can create new scenes. We have the other video where we created the environment using ProBuilder, so we can use ProBuilder to create custom levels, basically, and that's going to be your goal for a while, is to create a few custom levels and maybe add in some custom functionality as well if you can. Okay, so I'm gonna save that. I just want to make sure I've got, yeah, cool. Yeah. I'm gonna save that. Save this scene, and then I'm gonna commit this, and I get added UI to the game. And commit that to develop, and that's basically the game created at this stage. There's not much extra I need to do on that.